guys, it's Mike Mass. Welcome to another one of my RV instructional films. In this segment, we'll take a close-up look at Xantrex new flex panels as we install a solar array on our Renegade Super C. Aside from these new generation panels being lightweight and flexible, they add a whole new meaning to the term easy installation. In this film, we'll talk about the flex panel's high performance and rugged design, then I'll take you topside of our Renegade to witness just how easy they are to install and wire. In just hours, you can have a professional-looking aerodynamic design system such as the one we installed on our lithium-powered Renegade. We'll also look at Xantrex other solar panel offerings, such as their 100-watt portable solar kit, complete with controller that can be deployed in just minutes for solar power anywhere or anytime. For conventional RV and marine installations, Xantrex's rigid aluminum frame panels, such as the one shown, is ideal for owners who prefer a more rigid installation. For owners looking for a more aerodynamic and flush design, Xantrex flex panels, such as the one we used, are easily installed using the provided self-tapping screws or simply taped down for a high-performance flush solar system. As a perfect match for our Renegade's 8,000 watt-hour lithium battery system, which is even capable of running the roof air conditioner, we chose 8 of Xantrex 110-watt flex panels. These lightweight panels, weighing just 5 pounds each, can be installed using either screws or taped down. Since the panels are flush in design, there's no roof obstructions to accumulate leaves and debris or catch tree branches. Our flex panels are designed with eyelets for secure mounting. After laying the panel in position, you just fill the eyelet with clear silicone, then secure it in place with the provided self-tapping screws. These same panels can also be secured using Eternabond tape. As another option, you can also choose Xantrex more permanent peel and stick solar panels. We chose the screw-down version, so in the unlikely event a panel was damaged from a tree limb or hail, it could easily be replaced in just minutes. Okay, I'm going to turn the microphone over to Linda, who's been my partner converting this Renegade to lithium power, as well as the design and installation of this solar panel system.
Hey guys, before we begin our Renegade installation, let's chat briefly on Xantrex's portable 100-watt panel kit. Having its own solar controller makes it a great carry-on for travel trailers or marine use, with the ability to charge any battery at around 5 amps. Here on our 40-acre tract in North Georgia, we use our panel for recharging our ATVs, our generator battery, or even topping off batteries on our farm equipment. Each of its 3 panels has its own standoffs, allowing them to be angled for maximum output. When you're finished, the panels fold up in seconds, with the controller and wiring stored in its own pouch. Moving up to the Xantrex rigid solar panels, these aluminum frame panels with their MC4 connectors are offered in a variety of wattages. The panels are easily installed using the supplied standoffs, or as an option, the brackets may be taped down. Getting back to our installation, there are 4 main components of each solar installation. There is the solar panels, which convert sunlight to electrical energy, the solar controller, which regulates the panel's voltage, the house batteries, which store the energy, and finally the inverter, which converts the DC power to AC to run our coach's appliances. Without getting over technical, there are primarily 2 types of solar panels. They are monocrystalline and polycrystalline. Our Xantrex panels use the more efficient monocrystalline since they provide the most wattage per square inch. The solar panels absorb photons from sunlight to generate current. As the photons enter the panel, they separate and are absorbed by P and N-type semiconducting silicon material, which is separated by a conductive layer. As the electrons separate, they create direct current, which is gathered by thousands of microelectrical wires, which terminate to the panel's MC4 connectors. Our Xantrex flex panels use an exclusive mesh grid construction with a non-reflective flat black coating. This allows the panels to absorb maximum energy with minimum reflected light, making them more efficient than common reflective glass or flex panels, which use a shiny surface that can reflect up to 20 to 30% of the sun's energy. Every RV solar system requires a solar controller. The purpose of the controller is to convert the panel's voltage and amperage to a usable level to charge the batteries. There is basically two types of controllers: maximum power point tracking, or MPPT, and pulse width modulation, called PWM. Our system uses MPPT smart tracking technology. Therefore, it provides the most efficient use of the cells. Controllers are offered in many different sizes to accommodate the panel's voltage and amperage. Therefore, you'll need to select a controller which will accommodate your particular panel's output levels. Controllers, such as the Xantrex 30-amp model shown, also include a lithium battery protocol. Some installations will use two separate controllers and panel sets to avoid shading losses. Most controllers offer a remote control panel, such as the one shown, for monitoring the system. Some controllers also offer a Bluetooth feature, allowing the owner to monitor panel and battery activity right on their phone. As we look at a typical controller display, on this day, our panels are generating 600 watts of energy and outputting to the controller 63 volts at 9.5 amps. As we look at the battery display section, we see the controller has converted the panel's voltage and amps to a usable level of 13.91 volts and charging our lithium battery at 42 amps. Once the battery reaches its maximum capacity, the controller then shuts down the panel's output. Each RV is equipped with two separate battery systems. The first set is called the chassis batteries. These are generally flooded batteries used for starting the engine, headlights, and accessories. The second battery set is called the house batteries. We'll concentrate mostly on this set since it's our solar panel's job to keep them charged. The house batteries are used to power the coach's inverter, interior lights, and appliances. House batteries are generally of an AGM type. Some RVs, such as our Renegade, are equipped with a lithium battery upgrade, where the AGM set was replaced with lithium. This provides 4 to 6 times the capacity with less volume and weight. Mike documented this lithium conversion on film, which you can find on our rvvolt.com website. Lithium provides the ability to run your appliances 3 to 5 times longer than AGM batteries. Having this ability means more off-the-grid time and less time running your generator. Let's look at a short clip which compares lithium to AGM and flooded batteries. Without getting over technical, a few key advantages of lithium systems is they can be discharged up to 95% rather than just 50% with AGM batteries. Lithium offers a 5 to 10 times faster discharge and charge rate. Most important to RVs, lithium is lighter and requires less space. The main advantage of lithium batteries for panels is their large capacity. In order to capture and store a full day of solar power using an 8 to 10 solar panel system, you'll need a lithium battery with the capacity of storing that much energy. Finally, the fourth component of our system is the RV's inverter. The inverter's main task is to take the solar panels and batteries' direct current and convert it to alternating current to run our RV's appliances, such as the compressor refrigerator, electric stove, or air conditioner. Most inverters are equipped with a battery charging circuit as well, so when we're plugged in, the inverter can recharge the RV's batteries. On this leisure RV, which Mike converted to full lithium recently on film as well, he used Xantrex's compact solid-state Pro 3000 inverter and Bluetooth display panel. This compact unit offers a full 150 amps for charging. Our lithium installation on our Renegade uses the powerhouse Xantrex Freedom 3012 inverter, which also has a 150 amp charger. This 8,000 watt-hour lithium battery and inverter pair is capable of running the rooftop air conditioner for up to 8 hours just on the lithium battery, or 12 hours or more with the help of the solar panel's output. We designed our 8-panel array in a series parallel configuration using 2 strings containing 4 panels each in series, which are then joined in parallel to the controller. This configuration keeps us well within rating of our 10-gauge wire and even allow for future expansion. The ratings of each flex panel is 18.9 volts at 5.83 amps. Since the 4 panel pairs are wired in series, we'll add the voltage of each panel together, which totals 75.6 volts. Since the set is in series, the amperage remains only at 5.83 amps, or the value of just one panel. Therefore, the output of each series sets develops 75.6 volts at 5.83 amps. Using a Y connector, our 2 sets in series are now joined in parallel to our 10-gauge wire. When we do this, our voltage remains the same at 75.6 volts. However, the amperage of each set is now added together for a total of 11.66 amps, well below the wire rating and length of our 10-gauge wire. In ideal sun conditions, our panel's maximum output on the roof will be around 75 volts at 11 amps. The solar controller will then convert this power to around 14 volts and charge our lithium battery at 60 amps. While some owners are under the impression our solar panels are only in place to charge our AGM or lithium batteries, this is really not the case. Somewhat like your engine's alternator, the panels can also provide raw, unstored power to run our appliances. To help understand how this works, in this example, our roof air conditioning is drawing 105 amps from our lithium battery as the solar panels are producing power. Even though our 8-panel system is capable of around 880 watts to charge our battery at 60 amps, in this example, an evening sun is generating only 500 watts and developing 37 amps to the battery's terminals. However, when we look at our lithium battery display, instead of the battery providing 105 amps to power the AC, it's now only providing 77 amps to run the unit. The reason for this reduced load on our battery is because our solar panels are providing 37 amps to the battery terminals. Therefore, instead of the battery supplying a full 105 amps to run the AC, our battery load is now reduced to only 77 amps, conserving the battery's energy and allowing for a longer runtime.
Okay, Linda, thanks. Keep in mind the best companion for solar panels is a lithium battery system capable of storing a full day's energy from the solar panels. By teaming up these 2 components together, it provides a whole new era in off-the-grid camping, allowing you to avoid the expense and hassles of today's overcrowded campgrounds.
This concludes our film on our solar panel upgrade. For further information on Xantrex solar panels, controllers, and inverters, visit their website at xantrex.com. If you would like to see other articles or films on RVs, we invite you to visit our personal unsponsored website at www.rvvolt.com. Thanks for watching.